So today we're going to look at Chapter 9. We're going to finish most of Chapter 9 this week. 9.4 is the last section we do. We're actually going to split that into 3 days. So we're going to do some of 9.4 this week, and we'll end up finishing it next week. But there's only 3 sections in Chapter 9 we do. So we're going to take a look at what's called parametric equations, a little bit of parametric graphing. Nothing you really need to do by hand. If you graph, we're mostly going to use the calculator. So parametric equations, basically, just to kind of show you some graphs, you can draw things that you otherwise really haven't been able to do, or things that may be kind of difficult because that's not a function. It fails the vertical line test. Very hard to draw that using y equals something, right? We could draw like that butterfly kind of looking one. Some of these equations are pretty complicated, so we don't really get into what the equation is to do it. You could look it up, but we're just kind of looking at different things you could draw. Okay, that one's kind of similar to the first one, except that's a little different. So all kinds of different equations we can draw with parametric equations. So we'll talk about what parametric equations are. We'll look at a few that are kind of neat, like some spirals, and one that's called a cycloid, has a pattern to it. Another one I was looking up before you guys came in. I think you say hypotrochoid. Not really sure, but apparently it's like almost looks kind of like a star kind of thing. Sometimes it's like more rounded. This one looks a little like pointier. I don't know. So it seems like a hypotrochoid is like a larger class of things because they graph an ellipse as a special case of it. Not really familiar with that, but you can kind of get an idea of the equations, right? Not too bad. There's a little bit of stuff to it, but it's not like pages and pages. Same with this one. Not too bad. But they're not interactive, so I can't change that number and see what the effect would be. That'd be kind of neat if I could play with it, but I don't think I can edit it. So, but if you look at all these equations, notice here it says x equals y equals. X equals y equals. Again, x equals y equals. If I go on the calculator and I press mode and I go to parametric, it says x equals y equals. That's one thing with parametric. When you want to graph, you need two separate equations to make one parametric graph. Right? One equation is for x values, another equation is for y values. So that's a little different. We usually use one equation for the whole thing. Well, you've got one formula that gives you the x part of your coordinate, and then a separate formula for the y value. Right? So let's take a look. You can call the two functions whatever you want. Function f and g, h and I, you can give them any names you want. But the idea is you're going to be given two functions, and the functions are going to be defined on what's called an interval. So an interval, basically, we'll get into it a little bit more, but it tells you what numbers you're allowed to plug in. Right? You can't just take a formula like, let me just go ahead to 1 just to show you, like this. X equals 1 minus 2t, y equals 2 minus t. You can't just put in anything you want for t, because I don't know what t before. No, they usually tell you what t can be. And they usually tell you like a minimum and a maximum. T can be from here to here. Pick anything you want between those two numbers. But you can't just pick anything you want. And that number, that range that they give you, that t can be between, it's called an interval. Okay, so we'll get into that more. So, kind of already said it, but the idea is you're going to have a function and another function. One function, in this case function f, is what's calculating the x values. Function y, or function g, is calculating the y values. What are the functions? I don't know. I didn't actually give you numbers in this one. But function f is giving you the x part of the coordinate. Function g is giving you the y part. And if you graph all the ordered pairs over that interval that you're allowed to use, the picture that you've created is called a curve. It's called a parametric curve. Now, technically, even if you drew a line segment that's straight, our book still calls it a parametric curve. So don't think of curve in the strict sense like, oh, my picture actually has to be bent. No, just anything that's drawn parametrically in our book is called a curve. And we usually don't give the curve a name, but in this description in the book, they called the curve C. So like, I don't know if any of these have names. I don't see names on them. But if I wanted to talk about these separate, it'd be easier if I just named this curve A, B, C. So then I could say, oh, look at curve B. Then you'd know which one I'm talking about. Other than that, we really don't name the curves. Okay, so you're going to be given two equations. Both equations are going to use the letter T. Right? So you'll have x equals, and then you'll have some function in terms of T. Y equals, and then some function in terms of T. Just like this. X equals, a formula with T. Y equals, a formula with T. Okay, there's another one, a little more complicated. X equals, formula with T. Y equals, another formula with T. But that's got an exponent, so that's going to change how it looks a little bit. Those two equations together, the one that gives you the formula for the x's and the one that gives you the formula for the y's, are called parametric equations. What are they parametric equations for? The curve you just drew. And now t, we technically don't call it a variable. Yes, it is the thing that you're plugging in for. Like they'll tell you you can plug in a number between 0 and 5. But what you really call t is the parameter. Parameters, it's like another way of saying variable, but it's the word that you use when you deal with parametric equations. And you'll notice that if you go to your graphing calculator and you're in parametric mode, I can't really do it. But yeah, this button right here that says x, comma, t, comma, theta, comma, n, it's not going to give you an x anymore. If you press it, like I just did, it gives you a t. Okay, so usually we use x when that's like what the variable is when you graph, not in parametric. Okay, the variable is t. Okay, any questions so far? So a little bit of vocabulary up front: parametric equations, parameter, curve, interval. I got one more kind of way you can look at it. I'll tell you one more word. All right, so if you have a pair of parametric equations, one for x, one for y, those two equations parameterize the curve. In other words, those two equations write the curve parametrically. As opposed to what other way? Well, as a function, like y equals mx plus b, or something like that. So if you've got a pair of parametric equations, those give what we call a parametrization of the curve. Okay, if you wanted to kind of spell it out simple, they give you a way to write the curve parametrically. Because parametrization can be a hard word to say. Yes?
What's that word after the in the Latin?
Equations, EQ,
Oh.
EQS, period, just equations. Okay, but again, key in that sentence, pair, two. If you go to graph something parametrically on the calculator and you only type in one thing like that, like say I put in 2t minus 5 and I hit graph, it's not going to work. Because what you've just done is you've told the calculator, okay, 2t minus 5, that's the x value for the coordinate I want you to graph. But I'm not going to tell you what the y value is. But you can't graph the coordinate unless you have an x and a y. You didn't put in a formula for y. And if you go to your table, Not sure. I don't really use the table parametrically too much. Let's just see what happens. Actually, the table feature doesn't really seem to do anything. So I thought maybe if you put in a number for t, it would tell you the x and the y value in the columns. It doesn't. Oh, I also didn't finish typing in the formula. Let's see if it does now. I bet it will now. Yep. So if you plug in an x and a y, each column tells you, all right, if you let t be 0, you get an x value of -5, you get a y value of 0. Right? So you can kind of use the table the same way you're used to, but we won't need it. Okay, parametric curves can intersect themselves. Also, sometimes parametric curves end where they start. Okay? All the ones that I showed you on the first page, I think they end where they start, because there's no discernible end point or start point. Now, if I did a spiral like this, there's definitely a starting point and an ending point. You can see. You might not know which one is which without more information, but you can definitely see something starts or ends there, and something starts or ends there. Okay? The only way it's hard to see a starting and ending point is if a graph loops back on itself, like a circle. Okay? Or if you had a wave that did something like this. You can't really tell where it started and where it stopped. Okay? Some we're going to look like that. Okay? You can't really tell, like a circle. And then some we actually are going to look at a spiral. You can definitely see where it starts and stops. So any questions on that idea that curves can cross and intersect themselves? All right. So one thing we want to be able to figure out is, where does a parametric curve start and stop? Well, as long as you give me the formulas for x and y and the interval, I can tell you exactly where a curve would start and stop. Now, unfortunately, knowing where a curve starts and stops doesn't really tell you what it looks like. Because just because you say it starts here, it stops here, are they connected with a straight line? Is it a loop? Is that maybe a circle? So maybe it looks like this, or an oval. I don't know. So it depends on the problem. All right. The way you figure out where a curve starts and stops is it involves 4 calculations. The starting point has an x and a y value. The ending point has an x and a y value. You have to find all 4. The starting x, the starting y, the ending x, and the ending y. To find where the curve starts, use this number, the one I just circled in the interval. The first number in the interval is the number that controls where the curve starts. The second number in the interval controls where it stops. So what do you do with each of those numbers? You plug them into the formulas that they give you. So you're going to have a formula for x and a formula for y. Plug this value into the formula for x, and then plug this value into the formula for y, and that'll tell you where the curve starts. To find where it stops, plug that into the formula for x, and then plug that into the formula for y, and that'll tell you where it stops. And usually when you write an interval, you've got the low number on the left and the high number on the right. Just like any interval we do all year, it's always low to high. So you could do like 0 to 5, or 10 to 13. Don't do 13, 10. It's backwards. Now, every time we've drawn a graph all year on the calculator, what direction does it always draw the graph in? From what to what? It always drew left to right. Hopefully you noticed that at some point. But if you type in sine, or you type in a line, or anything, it always draws left to right. It never drew right to left. Well, when you draw parametrically, the calculator will draw properly, whatever way that means, it'll always draw from the start to the end when you draw parametrically. So it might draw left to right, it might draw right to left. It'll go start to finish in that order. Okay, so here's two equations, one for x, one for y. And now they're telling me what I'm allowed to plug in for t. You are only allowed to use the values between 0 and 1. What values between 0 and 1? Any of them. 0.67, 0.5424, 0.984, anything you want. But you can only plug in values between 0 and 1. And it's not because you couldn't do the calculation if you plug in a number bigger than 1, like 3. You could, but they're telling you not to, for whatever reason. So this is your domain for your parameter, from 0 to 1. So find the endpoints of the curve. Okay, there's two. Start, end. Let's do the start. What value in that interval from 0 to 1 is going to control where this curve starts? Yep, the 0. So you're going to plug 0 into the formula for x and plug 0 into the formula for y. And that'll tell me where the curve starts. So let's plug in 0. 1 minus 2 times 0. So the starting coordinate has an x value of 1 and a y value of 2 minus 0, which gives me 2. So this parametric curve is going to start at the coordinate 1, 2. Any questions on how we got that? Okay. Where is it going to end? What value is going to control where this curve ends? Yeah. The 1. And again, when I draw this, it might not actually be bent, like actually curved. It could be straight. Okay? But again, that's what the book calls it, parametric curve. All right, so find what happens when you plug 1 in for x and 1 in for y. Plug 1 in for x into the x formula. 1 minus 2 times 1. That gives me an x value of what? Negative what?
1.
Negative 1. Yep, I agree. And y, 2 minus 1. Which is? 1. So think about these as coordinates. You've got the point 1, 2. That's where you're going to start. You're going to end at negative 1, 1. Negative 1, 1. Which way is this graph going to be drawn? What direction?
Right.
It's going to be drawn right to left. Okay, let's try it. So let's put in, I'm not going to explain all the options right now. Let's just type it in just so you can practice it. We've got 1 minus 2t and 2 minus t. Now you got to put that interval in there somewhere from 0 to 1. That interval is going to control what the graph looks like, where it starts and stops. What button on the calculator can you press to change what the graph would look like? Not the equation of the graph, but what you actually see. Yeah? Window. So when you go to window, you have a spot for your minimum value for t and your maximum value. The minimum value is 0 in this problem, and the maximum value is 1. Okay, your t step, just leave it on 0.1. I'll explain what that is later. Now my x min and y min and max, that's probably too big. I don't really need to go negative 10 to 10. My x's only go from negative 1 to 1. So I really could probably just do like negative 2 to 2. And my y's go from 1 to 2. So I'll go from 0 to 3. Just leave a little extra. And there's my graph. So this one did happen to be a line segment. Don't know if you watched it when it did it, but it did draw right to left, not left to right. That's what it looks like. Any questions on that? Can't really get the starting point and ending point from the graph. I mean, you can trace. Well, actually, that is the ending point. Not sure. Huh, that's weird. Because, see, so in my mind, I think I want to move left, right? So I'm pressing the left button. And it's not moving left. It's not moving left because you're controlling the value of t. When t is 0, that's as small as you can go. If you went left, that would be like trying to make t smaller. I can't make t any smaller. I can only make t bigger. As I make t bigger, 0.6, 0.7, 0.8, my graph actually moves to the left. Right? And it does show me right where this one ends. -1, 1, which is exactly what we got. Any question on that? That t step that I changed, that's important. But I'll tell you what that is in a little bit. All right, so sometimes what we can do is we can eliminate the parameter. What that means is take an equation that's written parametrically and put it back into the kind of equation that we're used to. Like y equals and x, y equals 2x, something like that. So when you eliminate the parameter, what you're doing is you're describing the equation in terms of x and y only. You are getting rid of the t. Think of the t as like a middleman, right? It's in both equations. There is a way to get rid of it and just go back to what we used to have, x's and y's. Specifically, when you guys eliminate the parameter, I want you to isolate y. I want you to get y by itself. How come? Because that's how we always graph when you're using function notation. Get y alone. So let's take example 1. I'm not even going to write out steps for how to eliminate the parameter. I want to see if we can just kind of figure it out. We're going to take example 1, which was the equations of a parametric line segment, and see if we can change it into something we recognize, well, like y equals mx plus b. That's the goal. Okay, so there's your formula for x, 1 minus 2t. Formula for y, 2 minus t. Same formula as we just had. Now, when I'm done, what letter did I say I wanted by itself? Right, so when I'm done, I want something like this. Y equals, and I want stuff on the other side. The stuff on the other side is going to have what letter in it? X. What letter is going to be gone when we're done? T is going to be gone. So we have to make that happen somehow. Does anybody have any thoughts how I can get rid of that? You have to use all the information that's up there. Yeah?
Make that x equation, like change it to be t equals like...
So solve for t in the x equation. So you could start by doing that. X minus 1 equals negative 2t. And then what would be my last step to get t by itself? Divide by what? Careful. No. Negative 2. And I'm going to do it here, and here, and here. Yes, I could have just put the whole thing over negative 2, but I want to think of them as separate. That x has a 1 in front of it. So that first one is really negative 1/2 x. And negative 1 divided by negative 2 is how much? 1/2. So there's a formula for t. It's not the answer, but okay. So there's a formula for t. Now, what would I do with it?
You plug it into the y equation.
Plug it into the y equation for what letter? for t. Right there. And once you do that, you're going to have y equals 2 minus, and now let's just write it up. Y equals 2 minus, now don't put t, put negative 1/2 x plus a half. Okay, so let's write our final answer. What are you going to have to do with that negative out in front? Distribute it. So this is going to be a y equals mx plus b. It's going to be like a line. So what's my slope going to be when I distribute out the negative? Yeah?
Positive.
Positive
1/2.
1/2. And what letter goes with it?
X.
X. And what about your y-intercept? Say it one more time.
1.5.
1.5, yeah. So we could just write it, if we're going to use fractions, let's just stick with 3/2, 1.5. You could put plus 1.5, that's fine. But that's your equation. So now, technically, if we draw that, and the original parametric graph, they should look the same. So let's see what happens. There's that one. Now I'm going to go back to function mode, and I'm going to type in 0.5x plus, just easier for me to use decimals on my calculator. Now, when I hit graph, is it going to look the same as that? I mean, so did I make a mistake with one of these numbers? It's not going to have a starting and an end point. Functions don't have starting and end points like that. They go on forever. So we're almost right. But we basically don't want all of it. We only want from like here to here. So how do we account for that? Well, we have a function now, y equals mx plus b. But there's one more thing we have to do. The original curve was only a small part of the function, not the whole thing. So make sure you restrict the domain. You tell me, when you give me that formula, say, here's your formula, but only draw it between this x value and that x value. Don't have to tell me anything about the range. All you have to do is tell me, hey, there's only certain numbers I'm going to allow you to plug in for x. Because if I allow you to plug in anything you want, you're going to get too big of a picture. So you've got to tell me there's a limit on these x values. And you have to tell me what that limit is. How can you get that limit? Go back and look at your starting and end point for the parametric equation. Where was it? Right here. So the smallest x value you ever had was -1. That's as far to the left as the graph goes. The largest x value is +1. So tell me that then. Tell me to only draw between -1 and 1. So here's your answer, but x has to be between -1 and 1. You cannot use a number beyond that. And now, if you add that condition into the equation, then it will draw it correctly. Okay, how do you add it in? You just put it in parentheses right next to the original. So take your graph, put it in parentheses, and then put both of those. You can't actually type it as a compound inequality like this. You have to type it like this. X is greater than or equal to -1. And then another condition, x is less than or equal to +1. That's the only way you can type in that condition. Now I'm going to hit graph, and let's see what it looks like. If I compare that to what I had parametrically, exactly the same thing. Yeah.
How did you get the 3/2 and the 1?
Just from distributing out the negative, and then 2 minus a half is 3/2. Or 1.5. Same, yeah. Now, technically it's not exactly the same. Does anybody notice the difference between those two on the right? There is something that's a little different, but there's nothing I can do about it. That's the best I can do. They what?
The way they're graphed, like the pixels.
Yeah, the pixels, it looks a little more jagged on the bottom. Nothing with that. That's about as smooth as I can do it because that's the best. It's the best piece of technology I got. But yeah.
If the blue line was drawn on the x-axis.
Yeah, this part really shouldn't be here. But when you draw in functions, calculators like to always put a value in for everything. They're not going to leave something blank, right? So they're going to still draw something when x is less than -1. So what is the calculator to default to drawing? 0. It'll just say, okay, it's just 0. Right. And when you get bigger than 1, it'll just say, all right, I'll just let it be 0. Right. But that's the best you can do. All right. So that's a big part of eliminating the parameter. You've got to solve it like it's a system of equations and use substitution. But then you got to put this restriction. Restriction has nothing to do with y values. Okay? Just the x values. All right, so let's try this one. Okay, so first I want to eliminate the parameter, so get the formula. And then I want to write the restriction. Now, before I do it, does anybody think they know what this parametric equation is going to look like? So nobody's really saying anything. So and that's good, because sometimes parametrically it's kind of hard to think what it would look like. Yeah?
You know, like a macaroni kind of going like up to the right.
You mean something like this?
Yeah.
Okay, so that could be like a square root function or something like that, or a log function. It's a good guess. It's going to be curved. This one won't be straight, but it's not curved like that. Right? Let's eliminate the parameter, and then I think more people should be able to tell me what it's going to look like. So which equation do you get t by itself? The x. So if you do that, that top equation says that t would equal what? X plus 1. Now, what do I do with that x plus 1? Yeah?
Put it in for t in the y equation.
Put it in right here. Put that in for t in the y equation. And that's going to be part of our answer. So I get y equals. Now, what do you think I'm going to have to use here? Because if I don't put these in, it would be wrong. Yeah? You've got to put parentheses. X plus 1 squared. There's your equation. What is that the equation of? Yeah? Yes. I gave you the equation of I gave you the parametric equations for a parabola. More specific, what's happening to the parabola? What does that plus 1 inside do?
Shifts it.
Shifts it, yep. 1 unit which way? Left, yes. Shifts it 1 unit left. Kind of hard to tell that looking at the parametric. When I asked that question when it was written as a function, people told me pretty much right away. So it's just because you're used to functions more than you are parametric. That's the only reason. Right? Now, is it the whole parabola, or should it just be a section of it? Just a section. So you have to tell me what that section would be. From what to what? Okay. What value is going to control? Look at your interval. What number in that interval is going to control where my graph starts? Yeah? 0. And now I am only interested in what's happening to the x values because you gave me a formula for x. This is a function in terms of x. So just tell me what I'm allowed to plug in for x. From what to what? Let's start with plugging in 0. What's the smallest x value that you would ever get if you plug 0 in for t in the x equation? What is it?
1.
No, I think you're going to go smaller than 1. Negative 1. So our x's go from negative 1. What's the highest x value that we would ever get? Yep, 2. 3 minus 1 gives me 2. So if you graph that parabola and you only graph it between negative 1 and 2, you will get the exact same picture that I gave you parametrically. Any questions on how we figured out the formula as a function and how we figured out the interval over which to graph it? Yes?
How did you know it was negative 1? No.
Because when I plug in 0 for t, I get 0 minus 1. Yep. So it does, yeah, that's how it works. Now, what we just did there is taking a set of parametric equations, getting rid of the parameter. We got rid of the t. Now we're going to look at doing the opposite. So what we just did is not always possible to do. I could give you a problem you wouldn't be able to solve. Okay. If I gave you this one, x equals 2 to the t plus t. It's not that long of an equation. There it is. And I said y equals 2t. And if I said to you to take that and rewrite it parametric, get rid of the parameter, you can't. It's not possible. There is no way to get t by itself in that equation. And the problem is you've got a t as an exponent and a t as a term. If you got rid of one of those t's, it would be easy. Get rid of that, x minus 2 equals t. Simple. Get rid of that, and now all you'd have to do is a logarithm. We talked about how to change from exponential form to log form. It would be t equals log base 2 of x. So you could rewrite this with a logarithm. Let me double check that. Log base 2 of x. Yeah. All right. So either way, you could do it. Combine them together. Now you gave me a problem. I can't get the t out of the exponent and out of being in that term at the same time. So you cannot eliminate the parameter. If you figure out a way, let me know. But it is always possible to go the other way. You can always take something that's not written parametrically and write it parametrically. It's almost cheating. It's like so simple to do it this way. It's kind of like a cop-out. It's like it's not even really, I mean, it's technically right, but it's a really cheap way to do it. So the cheap way to make something parametric, if it's not, is basically to just do this, right? Somebody give me a y equals equation. Any equation you want.
Y equals 4.
What? Well, that's a constant. I should have said give me a function.
Y equals 4 plus x.
Okay. I could do the one that you asked, but it would look the same. It wouldn't really show the point. You can do it parametrically. It just, I won't give you one quite that simple. So the second one you gave me is more like what you'd see on a test. So you said y equals x plus 4?
Yeah.
Or 4 plus, it doesn't matter. X plus 4? Okay.
I said 4 plus x, but x plus 4 works.
Okay. So, you want me to make that parametric. I need to write it as two equations. If I just say y equals t plus 4, and then I just say, okay, x equals t. I've done it. All I did was take what he basically said, I changed the variable to t, and I said x equals t. So think about if you were to go backwards now and put it back the way Lucas just gave it to us. Step 1, solve for t in the x equation. It already is. T equals x. That's what t equals. Now, look at t in the other equation. Use substitution. Take what t equals and plug it in. We just did this. The thing that we did is it wasn't as simple as that. We actually had to do a +1, get it, now we got t by itself, and then we plugged in what we got for t. Well, here, t is already by itself. So plug in what you have for t, x, and then it becomes y equals x plus 4. And that's exactly what he gave me. So it's just kind of a quick, cheap way to make something parametric. And it always works. Just change the variable they give you to t, and then just say x equals t, and you're done. And there's other ways you could do it too. That's the easiest. Yeah. Could definitely do, like I could do this one another way. It requires me to think a little more. But I could say like t squared plus 4. And then I would have to do something like, let's see. If I did square root of x equals t. So yeah, I think something like that would work, right? Because now, when I plug it in, look what happens. T equals the square root of x. I take the square root of x and plug it in right there. What's the square root of x squared? X plus 4. So there's another way to take his same problem and write it parametrically. I think that's a little more confusing than the first way. But I basically just did two things that canceled each other out. So I would just stick with that. Okay, so let's try it here. I want to write that parametrically. Let's start with the y equation. Yeah? What would the y equation be? All right, so we've got the y equation. Now you need to write something here so that when you solve this equation and get t by itself and then substitute in, you get back what you started with. So what would you put for the x equation? Yeah?
Would it be the 4th root of t over 3 plus the 3rd root of t over 7 minus the square root of t over 8?
You don't even, it's going to be even simpler. Yeah?
Just do what? X equals 2.
Yeah, just x equals t. Okay, let's check it. Solve for t in the top equation. Already is. What does t equal? T equals x. Everywhere you see a t in this bottom equation, substitute in what t equals. If you do that, you get back the original problem exactly. And that's it. Again, you could make it a little more complicated. You could do square root of x and t squareds and stuff like that, but that's the simplest way to do it. Don't worry about like the interval, like, oh, well, what should the interval be? They didn't give me an interval to start with, so I'm going to assume x could have been anything. So I'm going to assume here t could be anything. Okay. I just wanted you to see how to do that. Questions on that? All right. So now we're going to look at a few special parametric graphs. First one is a circle. In order to figure out what the equation would be of a circle parametrically, what I want to do is forget about the whole circle. Just think of a single point. Just draw a circle and put a point on it. And think, how would I represent that one single point? Like this. That point has an x and a y value. It has a horizontal distance from the origin, and then it has a vertical distance from the origin. To make the horizontal and vertical distance from the origin easy to see in that picture, what shape could I draw? Yeah? Triangle. Like that?
No.
No. No, that wasn't good
No,
at all.
that was bad.
That was awful.
Yeah.
How would you draw your triangle?
I would draw my triangle from the origin to the point on the circle.
Okay. Like that?
Yeah.
Okay, anything else?
Yeah, since it's not really a triangle.
Yeah, it really isn't.
Yeah, you gotta draw the leg of the triangle.
Okay, and where would that go?
Yep, start right there.
Yep.
And then down 90 degrees.
Oh,
No,
oh,
you're almost there.
right there.
Good.
Okay. So now we got a triangle. Let's label a couple things. Let's make this side x, this side y. Here's a 90. Now, the hypotenuse of that triangle is really the what of the circle? Yep, it's the radius. So let's just call that r. And now, there's two things that would control where that point is going to end up. The length of r. If I made r longer, it could push the point out onto a circle out there. If I made r shorter, it could bring that point in. Right? So r is going to control where that point is, and there's something else that controls where that point is. What else controls where on the circle that point would be? Yep.
The angle.
The angle, yes. Now the angle is a variable because maybe that's an angle of like 40 or 30 degrees. But the angle could be anything from 0 to 360. So the angle is what we call a parameter. It's the thing that can change in the problem. The radius wouldn't, because if the radius was changing, it wouldn't be a circle. The radius has to stay fixed. So the parameter is the angle. And how do we represent parameters? What letter do we use? T. We normally use theta. Well, theta is fine to use when we're talking about an angle and we're doing it as a function. T is the thing that can change in the problem. Nothing else can change. Just the T. Now, let's think of a formula for y. From the perspective of T, what is the name of the side that we labeled as y? Opposite. What about the side we labeled as r? Hypotenuse. Which trig function involves those two? Sine. The sine of your angle equals what you guys just said. Opposite over hypotenuse. Now I'm trying to get a set of parametric equations. That means one formula for y, one formula for x. What's the formula for y? R sine t. That is the formula that will tell you the position of the y value part of the coordinate. What do you think the formula is going to be for the x part of the coordinate? Yep.
R cosine t.
Yes. And there are your two equations that you need to write a circle parametrically. R sine t gives you the y part of your coordinate. R cosine t gives you the x part. So now the next problem, I'm just going to tell you to write a circle with a certain radius. So just plug in whatever number I tell you for r, and that's all you have to do. So I want to know the equation of a circle at the origin that has a radius of 2. So what would be my x equation? Lucas?
Be 2 cosine.
Yep. And what would be my y equation? Yeah.
2 cosine. I mean, 2 sine. T.
T.
I'm sorry.
That's okay. It's the first time with parametrics.
It's the pressure of the.
It's the time of day, it's the pressure,
It's the recording.
it's the recording. I
Yeah,
know.
the pressure you get doing.
I'm sorry.
I have stage fright.
All right, so there's your equations. Now, t, remember, is a parameter. You have to tell me where to start t and stop t. If you don't let t be big enough, you won't get a whole circle. Just like we didn't get a whole line, we get a line segment. You might just get part of a circle. You might just get an arc. So T is an angle. What do you think T would have to go from and to get a whole circle? Yeah?
0 to 360.
Yes. If you're in degrees, T would go from 0 to 360. Let's just see what mode I'm in. All right, I'm in radians. So T would have to go from what to what? Not 0 to 360. 0 to 2 pi. So when I start to set this up, go to parametric, put it back in parametric, go to your window, 0 to 2 pi. If I was in degrees, I would have done 0 to 360. Now, T step. Just leave it at 0.1. That's fine. We're drawing a circle with a radius of 2. So I would set your window like -3 to 3. That's probably pretty good. Now, keep in mind, the shape of my calculator screen is what?
Rectangle.
It's rectangular. So if you cram the same amount of units in horizontally and vertically, but you're doing it on a rectangular screen, that's going to distort your image. Okay? That's fine, but just keep in mind what we're about to see is really circular. Right? So if I hit graph, you have to type in your equations. That's the old problem. 2 cosine t and 2 sine t. Doesn't matter if I close the parenthesis because there's nothing coming after it, but if you want to be really nice about it, you can. And now if you look, it really is circular. Look at the radius in each direction. 2, 2, 2, 2. Now, that's how it should look. Let me show you what happens if I change the t step to 1. I meant t step. So let's put that back at 2 pi and put the t step at 1. The t step is controlling how the calculator is going to graph. So you're telling the calculator, I want you to plot points using 0 to 6.28, and you are allowed to go in increments of 1s. So the calculator is going to plug in 0 for t. It's going to do it in the x and the y. It's going to plot that point. Then it's going to plug in 1 for t. It's going to plug in a 1 here and a 1 here, get the x and the y, plot the point. Then it's going to plug in, so 0, 1, 2, 3, 4, 5, 6. So the calculator is going to plot 7 points to graph that circle. What do you think it's going to look like if it plots 7 points? Yeah, it's going to look kind of like something with jagged sides. And they don't even connect. Because, think about where your interval is ending. It's ending at 6.28. The last value it was allowed to plug in for t was 6. It can't do 7. 7 is beyond the end of the interval. So when you go by 1s, you end up with a gap. Okay? If you go by 0.5s, it's going to look a little better. It's going to plug in 0, half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. But then it still can't do 6.5 because that's beyond, it's beyond the end. So you get that gap again. It's exactly the same size gap we had before. So what you should do is pick a number that's small, ideally a number that divides into the t-max pretty closely. That's a pretty messy number. But if you do 0.1, you're going to be able to graph 6, 6.1, 6.2. We're supposed to go to 6.28. Now we're only going to have like 0.08 of a gap. That's not bad. It's still, let me fix that. It's still noticeable, but it's gonna look pretty close. But you'll still see it, just barely. Now, if you wanted to graph it as a square, how many points would you have to plot for a square? Think about a square. How many vertices? 4. So if you say, okay, we went all the way to 2 pi, have it jump by quarters of that. So set your t-step to pi over 2. So you're going to get 0, pi over 2, pi, 3 pi over 2, 2 pi. It's going to end where it started. And now, you get, it actually plotted 5 points. 1, 2, 3, 4, 5. Okay? Now, so we know what the t-step should be. Okay, it should be about 0.1. Let's say you set it to 0.01. Now what you're doing is you're telling the calculator to count from 0 to 6.28 by hundredths and graph every single number you come across. So think about that. You're going from 0 to 6.28. That's 6.28 units. And you're plotting a point for every hundredth. So you're plotting 628 points to graph that circle. What do you think is going to happen when I hit graph? It's going to go pretty slow. Not extremely slow, like you can still see it moving. But it's plotting 628 points. That's overkill. For a circle, you don't need that many points. So try to pick a number that's a good balance between it looking jagged and too straight on the edges and taking this long. Okay, if you put in a really bad number, you're just going to have to hit second off, and that'll stop it. Because if I put in like 0.0001 and I waited for it to finish, the battery's probably going to die before it finishes. So you're going to have to stop it. So that's what your t-step does. So notice in that example we just did, the window itself, really, the circle only went from -2 to 2. Well, I'm not going to wait for it to draw again. But the circle went from -2 to 2 on the x-axis, -2 to 2 on the y-axis. But the parameter had to go from 0 to 2 pi. Now, what do you think would happen if you went beyond 2 pi? Like, let's say I go to 4 pi. What do you think would happen?
Two circles.
Two distinct circles?
Two circles that connect.
Okay. Lucas?
It wouldn't graph all the way, like there'd be a space.
You think there might be a gap?
Yeah, maybe.
Well, what would kind of be the opposite of having a gap?
Having no gaps.
Even more than having no gaps, if it did what?
Too much.
If it went too much, if it traced over itself. So watch, this is one you can only see by watching it. If you watch it closely, you can see it's tracing over itself. You could kind of tell because it got a little bolder. I don't know if you could you see it from the back?
Yeah, I can kind of.
It got a little bit bolder, and that's because the calculations might have been a little rounded. It's just because we're using decimals. But if you did it like 3 times and 4 times, it wouldn't keep getting bolder. Eventually, it would just reach a point. You wouldn't see it anymore. Right? But you've gone too far. You didn't need to trace over it twice. So I might ask you, like, what's the minimum the parameter could be to trace and get a full picture? Bless you. Let's look at this one. So here's a graph. These kind of look like the equations of a circle. This one and this one. Except what's different? There's one thing different in each equation. Yeah?
T shows up twice.
Okay, tell me where it normally would not be for a circle.
The coefficients of cosine and sine.
Right, it would normally not be there for the coefficient. What would be there?
R.
You would have had an R. R is what kind of value?
Radius.
And the radius in a circle, is it fixed or variable?
Oh, it stays.
It stays the same. So before, you had a fixed value in front for the radius. Now you have a changing value for the radius. What kind of shape would you get if you have a radius that's constantly growing? Think about it. A radius that's getting bigger and bigger with every revolution. Yeah? A spiral. That's what this is. In particular, this is 2 revolutions of a spiral. It's going to look like this. Now, look at the spiral I just drew. That's pretty much exactly where it's going to start and stop. Actually, it's probably going to start at the origin. But that's fine. The point is, when you set up your window, you're going to need the most amount of space in that direction, because that's where the spiral is going to end. So let's see the biggest the spiral could ever be. When you graph cosine, what's the biggest value you can ever get? No matter what you plug in right here. Cosine is always between what two numbers? Yep. -1 and 1. I don't care if you plug in 10 million and take the cosine of it. You're going to get an answer between -1 and 1. How about sine? Sine is always between what? It's always between -1 and 1. Even if you plug in 10 billion, take the sine of 10 billion. It's still going to be between -1 and 1. So, we have a limit on that part. The highest it can be is 1. What's the highest t can be? Yeah? 4 pi. So if you take the biggest that the cosine could ever be, which is 1, and the biggest that t could ever be, which is 4 pi, that tells you the biggest possible value you could ever have for a window. Now let's look at the smallest. If everything lined up just right, what's the smallest that cosine can be? -1, and the smallest that t can be is 0. So what that's basically saying is the smallest that the radius of the spiral could ever be is 0. What does that mean? The spiral is going to start at the origin. So the radius could grow as big as 4 pi, and it could be as small as 0, but the largest radial arm of the spiral is going to be in this direction. Right? And then the third longest, or second longest here, third longest, that's going to be the shortest direction for the spiral. Okay? So let's try it. Let's see what happens. So we've got t cosine t. So that's easy to change. T sine t. Now my window is 0 to 4 pi. Actually, I already have that in there. And t step of 0.1, that's probably decent. 0.1 gives you a pretty good curvature. But my window, I'm going to go 4 pi and -4 pi in every direction. That's a little bit of overkill. I don't need to go that big in every direction. Technically, just the part that goes to the right. That's going to be the longest arm of the spiral. But if we do this, we don't have to think too much about, where to put the biggest part. Just want pi. Second, pi. There we go. And 4 pi. If you just did -13 to 13, that would probably be easier on all of them. Hit graph. Here's one revolution of the spiral. Notice the arm is getting bigger, and it reaches its biggest. I just barely have enough room on my x max. So maybe I should make my x max 13. That's pretty good. Okay, so that's a spiral. The last one I'm going to show you is what's called a cycloid.
It's called a what?
Cycloid.
Oh.
And a cycloid has this pattern. Pick a number for A, like 5. The bigger the number, the bigger the cycloid. And then t minus sine t. Something like that. And then for the bottom one, you got to pick the same number. 5 minus, or in parentheses, 1 minus cosine t. Now, the bottom one is trapped. Okay? That y value, think about the largest and smallest cosine can ever go. Okay? Cosine is always between -1 and 1. So, biggest number you could have, 1 minus -1, that could be a 2. This could come out to a 2 in the parentheses. Smallest number you could have, cosine could come out to a 1. 1 minus 1 is 0. So what's inside the parentheses is always between 0 and 2, and then it's multiplied by a. My a was 5. So for me, I only have to worry about 0 to 10 on the y-axis. Now, the problem, I'm going to go a little bigger than 10. The problem is the x values. Right there. If t was like a million, well, the sign of t would be between -1 and 1. But then you'd have a million minus 1 or a million minus minus 1. That's huge. The bigger the t gets, the bigger what's inside parentheses gets. So x is unbounded. It just keeps on going forever. It doesn't keep repeating itself like y. So it takes a little practice to get used to what you might need to use. But if you try graphing this, you can see that's what a cycloid looks like. It's just a pattern, and it actually just keeps repeating. If you set x bigger, it just looks like this. That's called a cycloid. A little tricky to figure that out, but again, just like when you started in calculators, play with your window, play with your x min, x max, and you'll figure it out. Okay, so that's the homework for tonight on 481. We'll take a look at that tomorrow, and then we'll look at section 9.2.